G. Manually move the setting of the fixed length distance. We just set 100 mm. We also can set 80 mm. Press OK. Press F8. Restore to 0. Press to 80 mm. Auto pause. Press to move back 80 automatically. After setting the distance, manually press the arrow keys to stop the machine after moving to the specified distance. X. Modify cutting speed. When the machine is not moving, press Modify speed. Current speed is 1500 mm. It means run 1500 mm per minute. After manually entering the speed, press Enter. Confirm the modification speed. Y. Manual speed is the speed of walking during operation, machine speed of press arrow keys. Currently set as 3000, it means run 3000 mm per minute. F. 3 mode switching for manually moving. It's a fixed length approach, and it can be transformed into a linked way. The first one is fixed length, press the arrow key to move to the set distance. The second one is linkage, press the arrow key to walk, press again to stop. The third one is jog, hold the arrow key to walk, loosen to stop. N. The setting of the slit compensation value, press Shift N, to modify. The slit compensation value is half of the actual slit value. For example, the actual cut slit is 4 mm, half of the slit is 2 mm. Set the slit compensation value to 2 mm. After modification, press Enter. Press and hold Shift M, to switch. Conversion of 3 cutting modes. The first one is plasma. The second one is gas cutting. The third one is demo mode. Space bar, press on the main interface, can switch to the cutting interface. Del. Delete key, used to modify and delete parameters and edit mode. Generally, you can use it when editing the program manually. The first button, Ignition, is a flame cut ignition switch that can turn on preheated oxygen, but cannot turn off preheated oxygen. This button is not recommended. The second one is Preheat. Preheating oxygen button can turn the preheated oxygen on and off. It can turn on and off the low pressure oxygen and acetylene. Press the low pressure preheating to start the ignition. Press it to turn it off. Press it before cutting, ignition and tuning. The third one is Plasma. Plasma arcing test button. After pressing, the plasma will start to arc or cut. Generally used to determine whether the plasma works before cutting. If the plasma arc voltage level adjuster is not installed, this button is the plasma arc start test button. The fourth one is Piercing. Flame height adjuster switch. Generally small CNC does not choose to increase the flame, so this button is not used. The fifth one is Cut Oxy. High pressure oxygen test switch. The sixth one is Close. Close button can close all previously open switches. F1. Graphics library. This machine has 49 kinds of graphics. Press the arrow keys, select a graphic, press F8 to confirm, enter the interface to modify the size. There are lead in, lead out, size 1, size 2. Now we modify the lead in line 5 mm. The lead out line is 5 mm. The size 1 is 30 mm. The size 2 is 30 mm. So that is the graphic you want to cut. Press OK. Press F1 is the size of the piece. the size of the piece is the size of a workpiece cut, and F2 is the size of the hole, which refers to the size of the current frame and cuts from the inside of the figure when cutting. Introduce the operation process of copying the UDisk program to the host computer. Insert the USB flash drive first. There is a USB interface here. Press F2, and then press F2 UDisk file and press to switch the file. You can turn the page, select the specified file and press F6. To copy to the hard disk, pop up the window to modify the file name. Press Enter to confirm. Prompt: the copy is successful. Press F1 hard file on the hard disk file. Select the file you just copied and press F8 confirm or Enter to transfer the graphic. F3 Parts option: modify the file before cutting. Press F1 to locate the starting point. There are 5 positioning points: F center, F2 lower left, F3 lower right, F4 upper left, F5 upper right, F2 angle correction. Angle correction has 2 functions: F1 plate correction, F2 input angle. Input angle: the current input is 45 degrees. The graph will rotate 45 degrees counterclockwise, and the input 45-degree graph will rotate 45 degrees clockwise. The correction of the steel plate is mainly for the plate not being positively placed, not parallel with the main track. Corrected by F3 steel plate, the coordinates are cleared before use, and aligned. The position of the steel plate at the starting point is cut, and then the arrow keys are used to move to the corresponding point just positioned. Press Y to confirm the second point. At this time, the graph is rotated and corrected according to 2 angles. F3 repetitive arrangement: there are 3 types of arrangement. F1 array, F2 interlaced, F3 stack. A square: we want to typeset a few rows and a few columns, set to 5 lines. The line spacing is 7 mm. 3 columns, the spacing is also 7 mm. Enter confirm. F4 proportional scaling is to enlarge and reduce the size of the current graphic. The current graphic is a 100 × 100 mm square. We press F4 scale to enter, 2 twice, which means that the current graphic size is doubled to 200 × 200 mm. F5, select line, select number, select the number of lines. 1 line of valid code is 1 line, and select the number of holes. Each hole is cut into 1 hole. The line selection is mainly used to skip multiple parts for cutting. For example, there are 100 rows of parameters. It is required to start cutting on the 20th line, or you can input from the 5th hole. F6 code editing: after editing the code structure of the current graphic will be displayed, which can be used to learn G-code programming or modify the graphic. F7 graphics restore: pressing graphics restore will restore all the changes made in the component options. F8 confirm saves the current changes and returns to the main interface. Arc test. Piercing time. Adjust piercing time according to thickness of metal sheets. IHS height and IHS test. This one is IHS test. IHS means distance from cutting head to metal surface. Now we change IHS heights bigger to see how cutting torch move. Press IHS test, then you see cutting torch lower. Now we change IHS height smaller to see change. Press IHS test. IHS height should bigger than cutting height. As cutting torch should in high position when start cutting, in case cutting nozzles broken by spattered sparks. This is menu, used to set parameters of THC. But we do not suggest users change parameters, as all parameters set it well before delivery. If change, THC may could not work or have problem. Up and down of cutting torch. If pressing up/down when cutting, machine shall stop auto height control, then cutting torch go up or down. Lose up/down buttons, cutting torch will back to balance height of arc voltage setting button mainly controls the distance between the nozzle on the plasma cutting torch and the steel plate during the cutting process. The number can be adjusted. Generally, we recommend setting the distance between the nozzle and the steel plate in the cutting to be about 5 mm. Automatic manual button. When the automatic light is on, the ARC voltage height controller starts. According to what you set, if you say a distance of 5 mm, the cutting process keep cutting at a height of 5 mm. When you hit the manual, you have to adjust it according to the rising and falling of the cutting torch, cut and adjust at the entering the boot up state, we can press any key to enter the main interface. We can press any key to enter. Part 3, set the cutting method and parameters. We are going to cut a circle with 30 mm diameter and thickness is 5 mm. Let's find the circle first. The lead-in wire setting is 2 mm and the lead-out wire is also 2 mm. Radius size is set to 15 mm. There is a partial size and whole size in the lower left corner. We have to cut a circle and choose its size. If you make a hole in a steel plate, you can choose the whole size. Please press F8 or enter to confirm. Press X, choose the speed and plasma current size. Press Shift N to modify the curve value. In general, the actual curve is about 3 mm and the preset curve is 1.5 mm on the machine. The setting on the machine is half of the actual curve. If the cutting part is 1 mm smaller, please increase the curve value by 0.5 mm. If the cutting part is 1 mm larger, please reduce the curve value by 0.5 mm. Switching mode switching, press Shift M, and then switch to plasma cutting mode. Part 4, starting point selection. Move the back button, there are positioning point, bottom left, bottom right, top left, top right. We move to the bottom left position and then cut a 5 mm steel plate perforated from the middle. Set the perforation time. Set the perforation time. The perforation time setting is by adjusting the piercing delay button on the arc height controller. 0.3 is 0.3 seconds, and our 5-thick iron plate is set to 0.3 seconds. 1 mm steel plate setting is 0.1 second, 5 mm steel plate setting is 0.5 second. 10 mm steel plate setting is 1 second, 15 mm steel plate setting is 1.5 seconds. Part 6, Arc Voltage Setting. Adjust the preset arc voltage is 130. During the actual cutting process, the arc pressure setting height is about 5 mm clockwise rotation to raise height, counterclockwise rotation to reduce height. Less than 5 mm will be increased, more than 5 mm will be reduced. Part 7, Setting the Positioning Height. Press the IHS test button, the cutting torch starts the draw positioning. After positioning successful, cutting torch rises to setting height. IHS height is higher than 5 mm generally. In order to prevent the slag damage the torch after the perforation of steel plate. So we have a little more than 5 mm. Step 8, Start cutting. Press the space, enter the cutting interface, and then press Start button to cutting. The cutting torch starts the drop automatically, and it rises to the setting piercing height after positioning, and then starts the arc perforation. The setting piercing time is 1 second. The cutting torch starts to go after piercing completed. The balance height of the automatic cutting is set by the arc pressure setting to finish, and the cutting height of the cutting can be set to 5 mm. You can see that the 30 mm diameter circle has been cut. Next, let's measure the size of the cutting and see if there is any error. If has an error, you can reduce or increase the curve value. After cutting, the interface will show return or initial point. If you need to return, please press Enter. If stay without moving, please press ESC. The screen shows still on the way down but the cutting torch already walking. That's it. Let's we show it to you again. Troubleshooting methods. F4 parameter setting. F3 arc pressure detection in plasma cutting, choose it, then it will be OK. Let we show you again. The torch goes down and it does not move and locate successfully. Let we show you again, start. The torch goes down but it not move already be solved. Generally, the positioning method is to first drop the torch and touch the steel plate. Then set the height through the positioning height to lift the recovery arc. Arcing through the perforated delay. Perforated delay finished, then it can walk now. Below we demonstrate how to continue cutting if there is a sudden power failure during flame cutting or plasma cutting. Here are the samples that are set up for plasma cutting. The plasma cutting torch start to cut now. Let's simulate the power outage. After the CNC system is powered off, the system is black. Reconnect the power and wait for the power on. In the welcome interface, press any key to enter the main interface. Do not press the delete key, because the delete key will delete the graphic. After entering the main interface, press F7 to manually move the car, then press F7 to power off restore. Then the system enters the cutting interface, and the cross cursor will also move to the position before the power is cut off. Press the start button to start cutting. This function is more practical. After booting, press twice F7 to restore the position before the power is cut off. Let's introduce the process of importing pictures from computer into plasma cutting machine. The program has been copied to the USB disk. The first step is to insert the USB disk. Press F2 File Management, then press F2 U-Disk File. Usually the files we just copied into the U-Disk are in the back. Press S to flip the page. Press up and down key to switch the selected file. Press F6 copy file onto the hard disk. Press F8 confirm, show save successfully, then the program is already on the hard disk. Press F1 hard disk file, there is a program in it. Press OK, this program is coming out. Set these parameters after the picture imported: cutting speed, slitting, and cutting mode, including the arc voltage setting and positioning test. We have introduced in the plasma detailed video. I will not introduce it here. Next step, we choose the starting point. We can see the cutting arc in the lower right corner of the picture. However, the starting point of the new imported picture is in the lower left corner. We can change it when cutting. Move it to the lower right corner, then its moving distance will be shorter. Plus sign is the starting point. You see, it is moving. Press F3 Parts option, then press F1 Start option. Press F4 to select the lower right corner. Press F8 OK twice to see that the cross plus sign has moved to the lower right corner. We move the cutting torch to the lower right corner of the steel plate. Press S to lower the torch, and the torch can be moved by up, down, left and right keys. If the speed and distance of the movement are not well controlled, you can press the F key to switch to the fixed length mode to move precisely. We move to the approximate position first. Press G to enter a fixed distance, 1 mm, which will be better to control. It will move a millimeter by pressing. The starting point setting is completed. We press F8 coordinate to clear. OK, then we cut. Press space to enter the cutting screen and press the start button. If the window of the collision alarm pops up, press start twice to start cutting. In just a few seconds, it has been cut according to the picture you need. Common problem, such as the size of the workpiece we designed is 100 × 100 mm, but the actual cut size is only about 1/3 of its size, only more than 30 mm. In this case, some parameters in the settings exceed the limit and cause the system parameters to return to the factory default value. And our solution is very simple. Under the main interface, press F5 System Diagnosis, then F8 System Definition, and then F1 Restore Parameters. It is generally indicated that the restore parameters need no password successfully. If there is a need to enter a password, please enter 1396. The pop-up window indicates that the restore parameter is successful. Press the Enter key to confirm, then press the ESC key to return to the main interface. Let us introduce some reasons why the plasma cutting nozzle is easy to burn out. The first one is that the positioning height of your arc is too low, and the splash is easy to cause damage to the cutting nozzle when perforating. Let's try this height. Adjust positioning test. Under normal circumstances, we recommend that the customer position the height at 10 mm to prevent splashing. Let's see if it is larger than 10 mm. We will adjust this position smaller. 0.46 means the rising time is 0.46 seconds. Let's try again. Adjust to 0.4. Height is about 10 mm. 10 mm perforation height can effectively solve the nozzle burnout problem. The second reason, the cutting height during cutting is too low. It may cause the cutting nozzle to be too low or even in direct touch with the steel plate. The nozzle is easy to damage. The solution is that adjust the arc voltage during the cutting process. The distance keeps 5 mm. If the height is too high, please make reduce, and if the height is too small, then make increase. Adjust through arc voltage setting. That is to say, the height during the cutting process should be kept about 5 mm. The positioning height during the arcing process is kept at around 10 mm.